Hello and welcome to this video on how to run a one-sample t-test in SPSS. What I'd like to do is orient you really quickly to a new data set called improvedsanitation.sav, and then I will show you how to run the one-sample t-test and look at the output. Then I will show you how to create the confidence interval and look at the output for that one. And then compare those two methods of running the test and really what they each mean, and then what information comes from the output and goes into your report. So let's start off by orienting a little bit to this data set. It's called improvedsanitation.sav, and it has this variable view where you can see country. All the way here on the left hand side, you'll see that there are I think 225 countries in this particular data set. And then for each country, we have what's called, let me scoot back over here. We have Urban 1990, Urban 2000, and Urban 2015. So this is the year 1990, 2000, and 2015, so 25-year span. And this has to do with, here's the information that we have on improved sanitation in the urban area, and then those three repeat again: rural 1990, 2000, and 2015, so those three go together. And the national is just the combination of both urban and rural, so they've basically divided the countries up to see the access to improved sanitation facilities within the urban and rural areas, and then combine them for the national. So under variable view, let's look at that really quickly, and you'll see the same exact thing. Rows 2, 3, and 4 have to do with urban for the 3 years. Rows 5, 6, and 7 have to do with rural for those 3 years. And then rows 8, 9, and 10 are the combination, both urban plus rural. And if we look at the label here really quickly, what you'll see is these spell out really a little bit more. In other words, in 1990, for urban areas, what was the access to improved sanitation facilities? And this really is a number that is as a percent of the population. So for each country, they said our urban areas, looks like maybe 50% of the population has access to improved sanitation, and so on. So for your assignment, you will be looking at the national level. So for this example, let's go ahead and look at the rural level. Oh, one other thing that I wanted to point out here on the variable view page is that for missing, all of the places where there was no data at the time, when they collected it either in 1990, 2000, 2015, those missing are coded as a -1. And so if you'll see in here for Afghanistan, in the urban areas for 1990, they did not actually have information for that. So and it looks like across the board in 1990 we don't have information for Afghanistan. Sometimes for countries it's a different year. Sometimes even, let's scroll down here a little ways, for some countries we don't have it for the entire time frame, so we just don't have information for that particular country, but we've included them anyway in the data set in case sometime in the future we do have them. So that's a quick look at the data set. Next, I would like to run the one sample t-test, and this particular test is that, and we'll be looking at rural for 2015. We want to test if the average, if the population mean is equal to 58.11, and later on that number will make more sense. But for now, let's just say that we want to look at 2015 and see if that is equal to 58.11 or if it's not equal. So we're doing a two-tailed t-test. The way to do that in SPSS is to go to Analyze, Compare Means, One Sample T-Test. And here you have your one sample t-test dialog box. And we're going to take rural 2015. Remember, that's the one that we're testing. And the main thing to remember here is we need to put our test value in. And so here we're going to put 58 58.11. So that's the null hypothesis. H sub 0 is mu equals 58.11 basically. So that's what that means by test value. I'm going to click OK, and it will take me to my output viewer, and here is the output for my t-test that I just ran. Here's the sample mean, the number of countries. Out of 225, there were 192 that had a valid data. It wasn't a -1. So 192 countries. The mean was 68.585, standard deviation of 32.5 roughly, and a standard error of 2.35. Here's the information for my one sample t-test. The t-value is equal to 4.454. Degrees of freedom is this n minus 1, so 191. My p-value is equal to 0.000 according to this. Now that just means that it doesn't go to more significant digits, and you'll see what I want to do with that in the future. The difference between 68.585 and my test value of 58.11, you can actually literally do the math. You can take that number and subtract 58.11 and you'll get a difference of 10.47. And so that's the difference between what we tested and what the actual mean was that we calculated. Remember how we talked about that difference between how far away they are from each other. And then this 95% confidence interval of the difference is different than the 95% confidence interval of the population mean. And so this confuses a lot of people. So what I'd like to do is show you a way that we trick SPSS into giving us those confidence intervals. And so let's go back to where we were before, where we analyzed the one sample t-test. Go to Analyze, Compare Means, One Sample t-test. And if I change this test value back to 0, then what that means is that the 95% confidence interval of the difference ends up being the same thing as the 95% confidence interval of the mean. And I'll show you why that is in a minute. So here I'm going to go ahead and run that, and what you'll notice is a lot of the numbers on here are exactly the same as before. Our n is the same, our mean is the same, standard deviation and standard error are the same. The things that change are, here now I have a test value equal to 0, and my t-value, my p-value, this significance, this two-tailed, this is the p, sig means p-value, might be different. The t-value and the p-value and the mean difference for sure are different. So what you'll notice is the difference between 68.585 and 0, not surprisingly, is 68.585. So now we're relating to this test value of 0. And so the confidence interval that I create around that mean difference, 63.95 and 73.22, actually ends up being the 95% confidence interval of the population mean. So that's one way that I can get the computer to do the math for me, essentially. Now, if I were to scroll back up here and look at the numbers that they've created here, I could take this value, this 68, and I could do the math. I could calculate it based on the confidence interval of the difference. So I could use those numbers to calculate this, but I want the computer to do it for me because then I know that I'm not just going to make an error. So that's the way that you run an independent t-test in SPSS, as well as a quick look at the output. A very important thing to remember is that when you run this with a test value equal to 0, you cannot use the t-value or the p-value that go with it. And let me show you really quickly why that is. Here I've tried to kind of graphically show those two different tests. And so here's my 68.6, and I've rounded all these numbers just because it's hard to fit the whole thing in. But when I compare 68.6 to 58, I get the t-value for that particular test. Remember, the t-value converts to a p-value, and those two are specific for that particular test. When I calculated that and I got my confidence intervals, I am 95% confident that the true population mean is somewhere in between 64.0 and 73.2. Again, I've rounded these slightly, but just so that you can kind of get the general idea. 58.1 is not inside of there. So based on a 95% confidence or a p-value of 0.05, in this case I would say I would reject the null because it doesn't fall in the range where I would expect it. You would need to make sure you understand that concept. Now when I ran the test a second time, I used 0 as my reference value. And basically what that does is it creates automatically for me this difference. From 0 to 64.0 is 64.0. From 0 to 73 is 73.0. So let's go back and look at those confidence limits. Here's the 63 and the 73. Now when I ran the test this other way and I said I'm like 10.5 away from 58. What I was testing there is, let me choose a different color, how far away is the lower confidence interval from 58.1? How far away is the upper confidence interval from 58.1? And so it tells me that I'm quite a ways away. On average, I'm 10 point something away, and at the least, I'm at least 5 this 58 to 64, I'm that far away from it. So that's sort of the background of how these two tests are different and they get you different information. So when I test it with 0, what that gets me is it gets me the actual values for my confidence interval. When I test it against the value that I'm interested in, it gets me my t-value and my p-value. So essentially, when I test it against a test value of 0, the t-value and the p-value don't mean anything for this particular hypothesis question. So you need to be really, really careful to not use the t-value of 29 and this p-value here, which in this case ends up being exactly the same as the other one, or it appears to be, but don't use this t-value for the test value equal to 0 unless that's really what you're testing. You would need to go to the test value of 58.11 and get the t-value from this one. So one last thing is to take a look at the statistical report. And so here we are. We're conducting a one-sample t-test, so that's the part that I've just showed you. I've showed you how to calculate the confidence interval, so two things in SPSS, how to do that, and testing whether this average rural 2015 is equal to 58.11. And here's what the statistical test report looks like. You know how at this point to write a null and an alternate hypothesis. You know this is a one-sample t-test and that the assumption is normality of the sampling distribution of the mean, and whether the central limit theorem will help you achieve that when the data are so skewed as they are in this case. Here's the first piece of information that we get from our output. The t-value is equal to 4.45, and often when the t-value is greater than 1, we'll round that to the 100th place, sometimes even to the 10th. So you can give that information here, so that's your t-value. The p-value on the output says 0.00, and the thing that I like to point out is that that is a rounded number because we don't know exactly how far out this goes. How many more zeros are there until we hit an actual number? Remember, this p-value or this probability of getting the results this extreme or more extreme, that probability is anywhere between 0 and 1. And it really kind of goes on indefinitely because there is always a very minuscule probability. And so what I like to do, instead of saying the p-value is equal to 0, I like to say that it is less than 0.01, because that's what, if it was less than 0.005 and we rounded it, we would end up with 0.000 as the number that shows up in this rounded difference. So anytime you see this 0.000, I would suggest using a p-value is less than 0.001, or you could say less than 0.0005, which is also technically correct. So it depends just how precise you want to be. This is pretty precise here. So and then the 95% confidence interval of the mean is something else that you'll get from your output, and that's right here, 63.95 and 73.22. Notice that I rounded to the hundredths. Different journals, different statisticians have different ways of rounding, and some might even say to round here to the 10th. So you would want to kind of follow whatever is the convention. The bottom line is that if you include lots and lots and lots of numbers, it can be distracting and hard for somebody to look at that. So that's where my 95% confidence interval of the mean came from. And then my actual mean, standard error, and degrees of freedom can come from either one. Here's my mean, 68.59, and standard error of the mean 2.35, and my degrees of freedom 191. You can even just take the 192 and subtract 1 yourself if you want to do that in your head. So those are all of the numbers that are relevant to the statistical report that you would need to include, and then the rest of this, interpreting the confidence interval, rejecting or failing to reject the null, how do you write that decision in plain English, and so on, and then writing this out actually, as an APA format. So thank you for joining me for this video on SPSS.